Hi, welcome to another problem on RK method. This is also a question asked in the semester exam conducted in November December 2017. And the problem says using RK method of fourth order, we are asked to solve the differential equation dy by dx is equal to xy plus y squared subject to the initial condition y of 0 equal to 1. And it's different from the previous problems we have discussed in the sense there in the previous two problems we are asked to find a y at a given point of x, given one point of x, but here we have to find y value at three different points of x, that is x is equal to zero point 0.1, x is equal to 0.2, and x is equal to 0.3, and we are given the initial condition y of 0 equal to 1. So let's as we do in all other problems, we choose the explicit form. The explicit form of a differential equation is dy by dx is equal to f of x comma y. So comparing this with the given problem, we get f of x comma y is equal to xy plus y square subject to the initial condition y of 0 equal to 1. Because we have to get the y values at point 1, point 2, and point 3 and the given x naught. So from this initial condition we get x naught is equal to 0 and y naught is equal to 1. We choose h is equal to 0.1 by choosing h is equal to 0.1, we get x1 is equal to 0.1, x2 is equal to 0.2, and x3 is equal to 0.3. So in this lecture let's find the values of y at 0.1 and 0.2, and I leave as a task for you to compute y at y is equal to 0.3. That is, we have to apply RK method thrice to get the value of y at these three given points. Now let's try to get y of 0.1. So by taking x naught equal to 0, y naught is equal to 1, and h is equal to 0.1, let's compute the auxiliary constants. K1 is equal to h into f of x naught comma y naught, that is equal to the h value is 0.1 into f of x naught is 0 and y naught is 1, that is equal to 0.1 into, this can be factorized as y into y minus 1. This can be factored as y into x plus y. So by the rule of f of x comma y, we get this to be 0.1 into y, that is 1 into x plus y. So k1 is equal to 0.1. Now let's find k2, and the formula for k2 is K2 is equal to h into f of x naught plus h by 2 comma y naught plus k1 by 2, that is h is 0.1 into f of x naught is 0, h is 0.1 by 2 comma y naught is 1 plus k1 is 0.1 by 2, that is equal to 0.1 into f of 0.05 comma 1.05. That is, by the rule of f of x comma y, we get 0.1 into y. Y value is 0.05 into x plus y, that is 0.05 plus 1.05, and this value is going to be 0.1155. So we have K2 is equal to 0.1155. Now K3 is equal to h into f of x naught plus h by 2 comma y naught plus k2 by 2, and that is equal to h, that is 0.1 into f of x naught 0, h is again 0.1 by 2 comma y naught is 1 plus k1, which is we got just now, it is 0.1155 by 2, that is equal to 0.1 into f of 0.05 comma 1.05775, 1.05775. That is, by the rule of f of x comma y, it is going to be 0.1 into 1 point, that is the y value. Y value is 1.05775 into x plus y. X is 0.05 plus 1.05775, and this finally works out to be 0. Rounding off to 4 decimal places, 0.1172 is the value of K3. And now we proceed to find the fourth auxiliary constant K4, and it is given by K4 is equal to h into f of x naught plus h comma y naught plus K3, that is equal to h, it is 0.1 into f of x naught 0, h is again 0.1 comma y naught is 1, K3 is 0.1172, which reduces to 0.1 into f of 0.1 comma 1.1172, that is equal to, by the rule connecting x and y, that is f of x comma y, it is 0.1 into y. 1.1172 into x 0.1 plus y 1.1172, and this on simplification gives us k4 is equal to 0.1360. And now the incremental value for y, delta y, is given by 1 by 6 into k1 plus 2 k2 plus 2 into k3 plus k4, and substituting the auxiliary values for the auxiliary constants, we get 1 by 6 into 0.1 plus 2 into 0.1155 plus 2 into k3 value 0.1172 plus k4 value 0.1360. We get delta y is equal to 0.1169. So on calculating the incremental value for y, that is delta y, we can find the value of y at the next point, that is for the first increment x. So that is y of 0.1 is equal to y of 0 plus delta y, that is y naught. Y of 0 is 1 plus 0.1169. So we get y1 is equal to 1.1169. So initially we were asked to find y at 3 different points of x, that is 0.1, 0.2, 0.3 and 0.3. Now we have got our y value at 0.1. So now we try to get the y value at x is equal to 0.2. So for that we take the initial condition to be, so to find y of y of 0.2, the condition is y of 0.1 is equal to 1.1169. If you have any difficulty with working these decimal values, we can also find y of 0.2 by taking h is equal to 0.2, or without disturbing h, by me retaining the h to be 0.1, we can find y of 0.2 by taking these conditions: x1 equal to 0.1 and y1 is equal to 1.1169. So from this we have k1, the auxiliary constants, k1 becomes h into f of x1 comma y1, that is h is 0.1 into f of x1 is 0.1, y1 is 1.1169, and by the same rule f of x comma y is 0.1 into y value 1.1169 into x, 0.1 plus y value 1.1169, and this simplifies to be 0.1359. 0.1359. Now we proceed to find the second auxiliary constant K2. K2 is equal to h into f of x1 plus h by 2, y1 plus k1 by 2, and we know this h value is 0.1 into f of x1 is also 0.1, h is 0.1, comma y1 is going to be 1.1169 plus k1 0.1359 by 2, that is equal to 0.1 into f of 0.15, comma 1.1849, 1.49, and by the assumption of f of x comma y, that is y into 1.1849 into x 0.15 plus y 1.1849, and this simplifies to be 0.1582. So we get K2 is equal to 0.1582. Now we find the third auxiliary constant K3. K3 is equal to h into f of x1 plus h by 2, comma y1 plus k2 by 2, that is equal to h value is 0.1 into f of x1 is also 0.1 plus h, the incremental value for x is 0.1 and y1 is 1.1169 plus k2 is the one we computed now, 0.1582 by 2. By simplifying the arguments of f of x comma y, we get 0.1 into f of 0.15 comma 1.1960, and by the assumption of our f of x comma y, it is y into, so y value is 1.1960 into x plus y 0.15 plus 1.1960, that is equal to 0.1610. So we get K3 is equal to 0.1610. Now let's find the fourth auxiliary constant in the process of computing y2. So the fourth auxiliary constant K4 is h into f of x1. If it is being the first step, it would have been f of x0 plus h. This being the second stage, we get x1 plus h, comma y1 plus k3, that is equal to h value is 0.1 into f of x1 is 0.1, h is also 0.1, y1 is 1.1169 plus k3. K3 is going to be 0.1610. So the argument of f becomes f of 0.2 comma 1.2779. So I'm applying the rule of f of x comma y, it is y. So 1.2779 into x 0.2 plus y 1.2779, and on simplifying the values we get 0.1889 is the value of K4. So now we are ready to compute the incremental value for y, the second incremental value for y, that is from y1 to y2, and it's given by the usual formula delta y is equal to 1 by 6 into k1 k1 plus 2k2 plus 2k3 plus k4, that is equal to 1 by 6 into the k1 value 0.1359 plus k2 value, it is 2 into the k2 value is 2 into 1582, 0.1582 plus k3 value, it is 2 into 160.1610 plus k4 0.1889, and that is equal to 0.1605. So the y value at x2, y value at x2, that is y of 0.2 is equal to y value at x1 plus delta y, and we got y value at x1 to be 1.1169 plus delta y 0.1605. So we get y of 0.2 is equal to 1.2774. Now I leave the next part, that is computation of y at point 3, for you to practice, and in that process we have to find the constants k1, k2, k3, k4 by taking x2 is equal to 0.2 and y2 is equal to 1.2774, and using the formula for the auxiliary constants K1 equal to H into F of H into F of x2 comma y2, and K2 is equal to H into F of x2 plus H by 2 comma y2 plus K1 by 2, and K3 is equal to H into F of x2 plus H by 2 comma y2 plus K2 by 2, and K4 is equal to H into F of x2 plus H comma y2 plus K3, and the incremental value delta y is 1 by 6 into K1 plus 2 into K2 plus 2 into K3 plus K4, and the y at point 3 is equal to y at point 2 plus delta y, and that you will be approximately getting 1.5041, and I'll leave this as a task for you to complete. Okay. In the next lecture we will meet with a different method